All right, welcome back to another Mr.G EV Hangout. I get to hang out with my electric vehicle conversion friends, and we talk about topics. We cover kind of topics on everybody's mind, and that could be the battery management system. That's tonight. All right, that's a big deal. Why do you need to manage the batteries? Why is this important? We're going to go over it, and we have a very special guest tonight, along with our round table of community. Kelan is here from Thunderstuck. How you doing?
Hey, yeah, my name's Kelan. I've been working at Thunderstuck for about 5 years now. Started when I was like still doing school, and as I moved through school and through work, I kind of moved higher and higher, you know, in the work that I do. So I've been doing a lot of work with engineering and the BMS and a bunch of other fun projects.
This is the most important part of your career. Forget all that. This is it. Talking to layman people. This is the massive. No, I'm just kidding. Thanks for being here. I really appreciate it.
Yeah, it's really awesome to have so many like committed people in this community for sure.
Cool.
And we got stuff from Thunderstruck, not just BMSs. They sell chargers and all kinds of other stuff. They specialize in electric boat conversion products. And there's always new R&D on the way. And especially, I've used your charger for years now. It's awesome. Yeah. J1772 ready. You plug in to a regular charger, and it's up and working. So
nice. The man speaking right now is Kevin. How you doing?
Hi, good. Thanks for having me.
Kevin is a contributor of the Electric Vehicle Learning Center and is a Harley-Davidson software engineer. I also got a lot of DIY projects. So cool. In the house with them tonight, we got Mark Weller. He's an instructor in Southern California. How you doing?
Doing good.
All right. And luckily joined new electric vehicle conversion artist, Sarah Lyons. How you doing?
Hi. Thank you. Glad to be here.
And Sarah's converting some cars, and she's come in to join the community. Very cool. All the way from the Philippines, Tom Summers, our they call him the abuelo. He is the man, the myth, the legend, the excitable Tom Summers. How you doing?
Yeah, hi everybody. I'm so glad to be here.
And we got Jonathan Knight. How you doing? You got a project on the bench right now?
I do working on a conversion myself, and I'm excited to hear from Kelan because he's been an incredible help to me. I've got a long string of emails back and forth solving tons of problems. So
yeah, I'm happy to see you here today.
Yeah, good to see you.
Yeah, this is so fun. I'm glad everybody's here. It's like a round table. We also got Richard Jones. I don't know if you could hear us.
I hear you.
All right.
Yeah, I've used the BMS on one of the projects in our EV Riders Club, and it's going well.
Nice.
Nice to meet you.
Nice to meet you too.
All right. So yeah, and Richard's part of the EV Riders and the general EV guy. Me myself, I teach high school auto and metal, Mr.G, and I've done a bunch of conversions in an educational setting, and I'm always learning. So tonight's one of those nights. I'm going to school. Here we go. All right, so we're just going to go down a list of typical questions. What is the BMS? Starting with that, obviously it's a battery management system, but I think, Kelan, you want to just give us the most basic overview of the battery management system?
Yeah, sure. I mean, I think any of you guys could do this, but I think there's a few important points. It's the main thing responsible for keeping your battery safe, and also really controlling what goes in and out of your battery. I like to say that there's, a few jobs that are really important for a BMS, and people might jump out and say that, hey, its job is to balance the battery, but I would say that its most important job is just to monitor things, just to look at things, and be able to step in case something is going wrong, and even better, be able to control things more dynamically, bring a level of intelligence to your system that it wouldn't otherwise have. And then I would say balancing is relatively far down on the list of actually important tasks for it to do, on the day-to-day.
Oh, well, really? Man, I thought I guess the immediate the immediate protection of a battery is more important than balancing. You could balance later. Is that what you're getting at?
Absolutely, yeah. A BMS would be a decent BMS if it didn't balance at all. If you started out at a really good point of balance, you could go for a certain, a good period of time, and it'll handle that out of balance situation. It's the balancing of it is obviously important because you don't want to take the pack apart and manually balance all the time. But it's the thing it really needs to do really well is control and save your system. Yeah.
Okay. And what would be some examples of what it's controlling or saving a system from?
I mean, the easiest thing is charging. It needs to control chargers and potentially DC fast chargers. Yeah, and preventing, the things that can happen can go wrong during a charge. And then of course you got your drive unit, which is another big one, as well as like any smaller discharging things, DC-DCs comes to mind.
Got it.
So basically it's monitoring every single cell to make sure while you're charging, no cell goes above the maximum. And while you're discharging, no cell goes below the minimum.
Exactly, yes.
And also at the same time, they normally have temperature sensors in them too, to make sure nothing is getting too hot.
Or too cold.
Or too cold, yes.
Yeah.
And then just for layman's purposes, people who are listening to this and they're coming into this for the first time, basically the BMS is checking every single cell, not in the parallel, but in the series. And, so let's say, just think of a flashlight and there's two batteries in there. One of them might be out of balance, or you need to check one versus the other, see where they're at. And then if one's too high, it needs to shut off the charger before you go through the threshold. What can happen if you overcharge one of these batteries?
Well, I think we're lucky that I personally haven't seen anything too catastrophic yet, but we all know, I think inherently, we've seen in the news, bad things to happen to EVs, even Teslas, everybody has had it happen when you get to a certain scale. But
a thermal event.
A thermal event, yeah.
Yeah, you get fire.
Yeah.
But basically, I've never seen it either. As long as you are, protect your cells and monitor it, you can check it yourself. So moving to the go ahead.
At Harley, when we were testing some batteries, we would charge them to the point of exploding to make sure to see what happens and how does that propagate. So we purposely would do that. And famously, Neil Young's, what was his first Lincoln Continental EV conversion burnt to the ground. And other EV conversions have burnt to the ground also, and production cars from this. And it's super rare. It's much more prevalent for gas cars to catch on fire for some reason. But for some reason, when electric cars catch on fire, they seem to make the news much more.
Yeah. Okay. Kelan, let me ask you a question. What are your top three most popular questions or problems that pop up when it comes to the BMS? I'm sure when people go to install it or when they operate it, and this is all, well, I'm not going to say all, but we're in the DIY space. But I had someone on Instagram get mad at me because they said it's a professional organization. We're not DIY. And I'm like, did you buy it from an OEM? And they're like, no. I'm like, all right, you did it yourself. Then it's DIY in my eyes. So in the non-OEM world where we're installing this stuff with just our hands, what's the top three biggest mistakes you see people making?
Oh gosh, I have to narrow it down to three.
All right, give us however you want to structure it. Give us number one then.
We could probably go to top five.
It's too many.
There's so many. There's so many. I don't know. Like a big one is
what happened yesterday. Try that.
No doubt. Yeah. I like a big one we see all the time is like I've got this Hyper 9 system, 96 volts, and I really want 120 plus miles of range. So I'm going to take all these Tesla modules and I'm going to build like 3 packs and then put them in parallel. And it's not impossible. Don't get me wrong. You can definitely do it, but it's like, it seems like something that seems so easy to a beginner. But when you start like learning more about the tech and how it all works together, you start to find that that sort of thing is not trivial. So I get people coming to me all the time. It's like, I got all these LG Chem modules. I'm going to make a 96S 5P pack. And I'm like, you have no idea what you've just done. Like, I wish you had come to me first and asked if that was even possible, you know? Like one thing is just how many cells you have to monitor in that case. It's expensive is one word, but complicated, dangerous are other words that you could use to describe it.
Okay.
And I've had this conversation with Michael Bream at EV West.
Oh gosh, yeah.
He assumes when he says you should parallel all of those cells. If you are doing this parallel system where you've got the cells in series, you need to make the voltage, and now you want more range, so you're paralleling these together, that you should also parallel the BMS leads. Is that how you would do it?
I'll never like talk bad about anybody in this community, but I would never personally recommend anybody do that, frankly.
So is that because you're trying to sell more BMSs, or because you honestly?
Yeah, you got me. No, it's about failure conditions. It's about what happens when something goes wrong. If you lose one of those BMS leads, or a whole section of them, is there even a way to know that? You know, if one module or one cell is going particularly bad, can you really well define what the current across those leads is going to be, and can you protect it? You know, there's a lot of, I think, potentially uncontrollable situations that can arise from something like that, and there's a reason that you don't see it in the OEM, the professional world.
Okay.
And hey, they're doing this with our BMSs, so if it was to sell more BMSs, then that's not really the issue here, because I'm sure they would too. But
right. So instead, in the simple case where you only got 4, let's say you got 12 batteries, okay, and now you're going to put 12 next to that and parallel them, you would actually use 2 different BMSs in that case for each of those parallel strands, rather than one BMS paralleling each of the battery cells together.
that is correct. Yeah.
Okay.
I mean, the ideal way overall is to parallel cells individually. You don't have to worry about any of this.
Okay. So rather than in the module level, you're saying at the cell level, which is
At the cell level,
modules have inside them anyway.
Right. I know that's not really feasible when you're working with most or all modules, but
yeah. Okay, that's a good one. That's an excellent problem. And yeah, I have a battery set up on my bench here I've had for over 1.5 years, just sitting there, because the idea of wiring these up in parallel feels wrong and scares me. So I've not finished it yet.
I mean, I kind of have to put one foot in one world and one in the other. There's what I'm aware of in like the OEM world, in the safety world, what we have to put in technical documentation, and then there's what people really do. You know, people do this. There's probably nearly 100 projects out there that have done this exact thing, and I haven't seen an example of it failing yet. But I can only.
Richard dealt with a car from one of our club members who had this parallel thing, and figuring out what was wrong was a nightmare for him. And
also, the wiring is a nightmare.
Yeah.
The wiring.
Okay. Good one. Okay.
So okay, I think that we might have to get to failure questions. I think Sarah and Jonathan had some questions, and I have a question as well. Maybe that would be a good way to segue, and then we could get into some of the other things on the list. Jonathan, you had a BMS question, is that right?
Yeah. My question was around the relative safety of the cell taps, because I've read stuff online where people talk about how there's a lot of voltage potential, there's a lot of amp potential within the wires, even though they're little 20 gauge wires or whatever. But it's kind of seems like they should be pretty safe, but
yeah, I mean, I take this. I've seen both happen in real life. You can do a short with lithium with a 2-gauge cable or 2-aught cable, and you can do it with a 20-gauge cable. Really, at least in the moment, that event feels very similar. Unless you have a fuse, which you should. The fact that it's a smaller wire does not really bring you much safety.
so it's still the case that you should be sure to have those wires isolated and ultimately inside of a box and not running wild throughout your EV conversion.
That's the key, I think. I think a lot of the safety just inherently comes from the fact that all of this should be occurring inside of one sealed container. You can get away with a lot of things that would not be acceptable outside of the pack, because it's well known that once you've opened up the pack, it's a different beast.
And basically, what's nice about this situation is that you run the lead wires into this module. I mean, this is probably the wrong module, but the idea is you run it into a module, and then CAN bus is running out of it, and so you're not running any voltage. Sorry, you are running voltage through CAN bus, but you're not running voltage with a lot of amps behind it out of the pack.
Right. And it's distributed, so you can even have multiple packs and not have to worry about running high voltage wires all over the place.
Okay.
It's a serial that communicates with that unit there.
Oh, okay. Yeah. So now I got Tom Summers has got a hand up. Go for it.
Yeah, hi, Kelan. I'm really glad you're on here. We see, thanks to Kevin, readouts of your cell, all your cells, and they're to like three digits to the right of the decimal point. I was just wondering, what is the limit of a system, generally speaking, that would, like in Sarah's case, cut off the charging?
Do you mean like overall like voltage maximum, or the difference between like the highest and the lowest cell?
Oh,
Yeah,
okay.
both of those, but yeah, thanks.
Tom, are you talking about the high voltage cutoff for a lithium cell?
Yeah, I'm talking about the discrepancy between the cells. When you see those numbers on your diagnostic readout, what's going to be the high and the low limit, generally speaking, yeah, there you go.
Yeah. That's actually, I think this is a very good question. Obviously the maximum and the minimum voltage altogether depends on your cell. I think we generally like to go by 2.8 volts to 3.6 volts for lithium iron phosphate, and 3.3 to 4.2 for cobalt based chemistries. But for the spread, I think is a more interesting question, because like for our BMS, generally, if your cells are spread 3 millivolts, which is that 3 decimal place unit you were talking about, it's not even going to try. It doesn't really care. But when you start talking about spreads in excess of 30 millivolts, then you're starting to look at that you might have a problem. And this is specifically at the top of charge. And it depends on how big your pack is too. If you got a 500 amp hour pack, you're going to want these voltages to be kissing each other, right next to each other. But if you have a really small pack, 20, 30 millivolts might just be fine. And another thing is you said like how much does it matter until you have to stop a charge? Generally, I think most BMSs won't actually really they'll declare a warning for a high imbalance level, but they're not going to declare a fault. They're just going to do the best job that they can with the state that the cells are in. Just protect the highest and the lowest cells more than anything.
Okay.
So in your system, though, is that a configuration? You could say if the maximum difference between cells is more than this, raise a warning.
No, the kind of threshold for importance before we start adding configuration is pretty high. So I just didn't think we don't think that that's probably not necessary unless you guys want something like that.
Okay, but that doesn't exist right now. Okay,
No.
because I know like in production vehicles like Teslas, if you have too much of a delta between high and low cell, it will give you internal warnings and pick your car in for service warnings. And
Sure. Yeah.
I've had that happen
Okay.
twice.
on your Tesla,
So yeah.
and what did you have to do about it?
Their only solution, because it was under warranty, was to swap pack. But there are now third-party shops coming out. If it's truly not a actual failure, I think at least one of my two was an actual failure, but it was a BMS code, and at one time I had it read, it was basically saying the pack was really out of balance. Now, whether it was out of balance because of a cell failure or because it was just it just could not, it drifted too far. But my first one, it got to where the car would not charge. It was so bad that my car would not charge, and that's why I had to take it to service because I couldn't charge my car.
You could still drive it at that point, but shouldn't charge it.
Yeah, I had 40% battery left, so I was like, well, yeah.
Right.
Okay. Now, Sarah, if you don't mind, I just want to introduce a piece of the problem that you came across. She had a temporary problem where she had a bad the 2-aught cable connection between 5 Tesla modules. One of them came a little bit undone, and it actually sent high voltage cutoff for cell 24 and 25, and that was in between the high voltage cable. If you have a bad high voltage cable, what does that do? Why would it send the BMS? Why would it overcharge just those cells? Is that a good way of describing what happened, Sarah?
Just real quick, it didn't come undone. It was a tight connection, but it had a little bit of electrical tape underneath the bolts.
Yeah, it was like a bad.
Oh
connection.
yes. Yeah.
It was like interrupted, I
Yep.
guess, but it was still tight, and there was still metal touching, but there was a little bit of electrical tape under there.
So my question is, why did that? Oh, and that was during charging, right, Sarah?
Yeah, during charging, it would cell 25 would reach high voltage cutoff HVC, and then it would shut charging off, and then it would say cell okay, cell 25 okay, but all of the other cells would drop significantly after that.
Kelan, is this something you understand? I was trying to figure this out. I don't get why I did this.
Yeah, I see this all the time. This is you could consider that like a high resistance connection, and it isn't actually overcharging the cell at all. If you took a voltmeter and you probed the positive and the negative terminal of that cell as close to the actual cell as possible. With Tesla modules, it's pretty easy actually. You would measure that cell probably very similar to the rest of the cells on the pack. What the BMS is doing, I think in this case, you probably had, you said it was between 24 and 25?
25 was reaching HVC, and and 24, 25, and 26 were all a little bit questionable.
Okay.
And it was like between two modules.
I would need to. I think I need to see a little bit more to say for sure. But generally, what I'm going to expect is that it's because the BMS is measuring the voltage between 2 points, and if somewhere in that in between those 2 points there's a cable or a high resistance connection, as you charge, the voltage measured by the BMS is going to be higher. It's just simple V equals IR.
Oh, because of the resistance.
Yes, exactly. Yes. And it's kind of like a passive safety built into the system, where if you have a ridiculously high resistance, it's going to start throwing errors simply because the voltage it's measuring is either too high or too low. The same thing will happen in the other direction. It'll read a very low voltage if you discharge it.
Got it. Okay. It's wild. So V equals IR again and again. Know
everywhere.
it, love it, understand it. Don't fight it.
Don't swim against the current. Yeah.
Okay. Yeah. Okay. Does that make more sense now, Sarah?
Yeah, totally. Richard has his hand up.
Yeah, go ahead, Richard.
Wondering if you
Sorry
could comment
about
on
that.
that.
What do you got, Richard?
Oh, sorry. I was just going to ask Kelan real quick, because I've seen these situations before where some issue has caused the BMS to read a high voltage on one cell, but then you also see the side effect of low voltages on nearby cells or some kind of bleed over effect. Can you explain what's going on there?
Sure. There's I believe that there's two separate things that can cause that effect. I think most commonly when you're going to see a high cell and a low cell right next to each other, that's actually going to be a single. So you have each cell really only has one wire that measures it. And when you have like three wires, so negative one cell, positive of that cell, and then the positive of the next cell, and then this wire becomes loose or disconnected, that it starts to float in voltage between, say you have two 3-volt cells, so you've got 6 volts altogether. It'll start floating between that 0-volt point and that 6-volt point. So depending on the current flow through the pack, exactly how well connected that wire is, you might see one cell reading 0.5 volts and the other cell reading 5.5. The real voltage of those two cells is still consistent, but because that wire isn't so well connected, it starts floating.
Okay, so go check all your cell taps.
Right. Yeah, definitely. And the other thing that might be happening is when any voltage on any of those individual wires gets either too high or negative, it actually starts trying to discharge energy through the BMS to save the circuit, save the microchip that's actually taking these measurements, and it starts influencing the measurements of nearby cells.
Wild.
Would it be safe to do an experiment? Let's say in that case there you have two cells and the center tap is just disconnected.
Yeah.
What would happen in that case? Or you said the two voltages would float back and forth, right?
Right.
And just the two adjacent, any further downstream or upstream would be okay, or can it continue beyond that?
I won't say that it's safe. You definitely start risking damaging things, especially when you start pushing current through the pack. I think the behavior, I've seen a few ways. One thing is the BMS, it might happen in such a way that the BMS will actually start trying to balance the higher the higher cell, and then that's it then trying to push current through that path. And I think what happens is it flips the two cells, and when it's finished balancing what was the highest cell, it goes, oh well, wow, hey, this cell over here needs to be balanced now, and it starts flip-flopping.
So good to turn balancing off if you're troubleshooting.
It definitely can, yeah, especially if you're if you compare, but you change something, you look at what happened before, you look what happened after, and start to try to build a theory around what that means.
Interesting.
Yeah, thank you very much.
Very cool. If you guys are okay, we're going to go to the next question. Why can't you just, I know that when the battery management is balancing, it's burning the high cell to kind of get it to match. Just an intuitive question without any backing up. I don't understand why. And I get this question all the time. Why can't you just take the high voltage or the high energy from one cell and just give it to the guy next to you who needs it? What is that an option?
What do you mean? You can? Yeah, you definitely.
Oh, you can.
No, that's something that exists for sure. You can go online and buy a BMS that does that right now.
Oh, really? Okay.
Yeah,
That's the LTEC ones that we've played with at the club. It will shuttle charge between the high and the low.
Okay.
Yeah. But you asked why? Why not do that, right?
Okay. Yeah, my question was why not? I didn't realize people were doing it. Now.
No, I'm saving you here.
Oh, okay.
So the why not is just because it's going to be more expensive.
And probably not necessary, right?
Definitely not. So,
okay.
You remember back at the beginning when I said, balancing is not the most important job of a BMS, in my opinion. And one of the reasons for that is it actually doesn't need to do very much of it. And if it does need to do a lot of it, then there's probably something wrong.
Gotcha.
Yeah. So you end up spending $1,000 more on your BMS setup and just not use it, basically, unless your pack is 15 years old and on its last legs.
Yeah.
I have out of balance conditions all the time with my junkyard pack, but I've seen with better packs, and that doesn't happen. That's not so necessary. So
we could get into it.
BMS is to have a very small resistor in there that it'll use to burn off the top battery, so get it even with the rest, right?
We could get like really deep into this about kind of the decisions that you can make about. I mean, you should top balance first and foremost, but more about like exactly when you need to be balancing. How you could go on forever about that. But another point I'd like to say, and this kind of returns to one of the most common mistakes I see or common questions I get is like, why isn't my pack balanced? And they send me kind of some data, and it turns out that they never balanced the pack in the first place. Maybe modules came from different places. Maybe it's just been sitting for years. And the BMS is just, frankly, it's just never going to be able to do that. Not with 200 milliamps. I keep saying it. BMS's most important job isn't balancing, and I would say like its job isn't even really balancing. It's maintaining a point of balance.
Okay, interesting.
So I wanted to ask a follow-up question. So for those that aren't as familiar as to why would you want to top balance versus middle or bottom balance?
Who knows?
Well, I mean, I brought it up because you said you recommend.
Yeah. There's a few reasons. Back in the day, we used to always bottom balance packs. I know a lot of guys who would build like lithium iron phosphate packs. Sometimes not even have BMSs or have really rudimentary BMSs. What's the one that like used a fiber optic cable and you had like a separate circuit board on every cell? Like
I remember having a separate little chip on every cell.
Yeah. Like back then there were not that many options, and many BMSs didn't even balance, didn't have any features at all except for, hey, you got a problem here, right? So I think people would bottom balance so that they felt comfortable putting the pedal to the floor, because there was not necessarily anything that would save your pack if there was a low cell, so that they'd feel comfortable that the controller's voltage minimum would take care of the pack for them. They don't have to worry as much about balance. I think these days, the reason that I and Tesla and VW and everybody in the industry use top balance is because, well, you have to pick a spot, and it just happens that you spend a lot of time right at the top, because that's the point where you're going to start tapering down the current in your charge, and you just spend a lot of time right there, and time is really the key when it comes to balancing.
Gotcha. I just want to welcome in. Is that Ali? All right. Just unmute yourself. There you go. And turn it horizontal. Ali is a volunteer at the EVLC, and he helped assemble the battery pack and all the wires. Oh my God, this guy was, if you just threw spaghetti and meatballs at him, he would turn it into a wiring harness. It was incredible. Go Ali. How you doing, buddy?
Hey, I'm doing well. Sorry I'm late.
No problem.
Good to see you. Yeah.
Yeah. We're just picking Killian's brain here. And we were just talking about battery balancing and BMSs and what their job is. So that's kind of a segue into we have a list of questions, but just a quick story. We had a situation with a bus that we did over the summer, and we put a Tesla 6-pack in there. And we had your BMS on there, and just to test it out, we went and charged, and we had immediate high voltage cutoff on a few of the cells within a minute.
We can even show the video. I sent you that.
Yes.
Yeah, I watched that. It was really cool because it's like a perfect representation of what I've seen myself and heard customers talk about. I don't think I've ever seen it on video that clearly before.
Dude,
that was really cool.
So clear.
And unfortunately, it means that you've got a bad Tesla module,
right?
but it
we figured out in the end. So
yeah, your misery is my entertainment.
Yeah.
Yes.
Oh, and I'm glad we captured it. So, I mean, the deal was, we plugged it into the charger, and within like a minute, it went into high voltage cutoff because one cell went to 4.20 volts, whereas the other ones were still at 3.8, 3.7. So that group of cells had lower capacity than the others because some of the internal fuses in the Tesla module must have blown. And
exactly.
It was full, whereas the other ones were not. So
yeah, I think even more than that, because I bet if you stop the charge, the voltage would drop back down significantly.
It did.
Yeah. So even more than less capacity, which it certainly had less capacity, it had a higher resistance as well.
Yeah.
Oh, really?
That module also had a pretty big delta before and after.
I'm trying to find the video.
I linked it in the link of videos to send you for this thing.
Oh, I don't know.
You want me to share? I'll put it up here.
See if you could send it real quick. This was the big party we had of people that were interested over the summer. It was incredible. Some of the people are on the call. Omar's here as well. I didn't get the chance to introduce him. It was such a good build, and there was a lot of people involved, and I was so proud of everybody. We worked really hard, like 9 to 9 every single day for like 5 weeks. It was really wild, and we had to pull that pack out several times. But what do you think was, when someone says bad, what do you think was bad about that pack? Like what do you think went on with those batteries? If you were to guess.
It's hard to say, really.
Yeah.
I mean,
no, that's fair.
I mean, if you got them like that, there's often, I mean, you have to ask why was the car taken apart?
Yeah.
Well, they weren't from a Tesla. They were from a Tesla originally. Then they were put into a Jeep, and someone gave up on their project and then donated it to the EVLC, and then we got it from there. So there was some sort of failure in between there, and
I mean, yeah.
Also, when we after the first problem, when we first pulled it out, we visually inspected as much as we could without opening up the modules, and it appeared that all of the fuses were still intact. So from an external inspection, we could not discern anything physically on, but obviously there could be internal problems. But
okay, yeah. So basically, there was either some bad cells or whatever it was, and we caught it with the BMS. Tom's got his hand up. Go for it.
Yeah, I just wanted to clarify that it was we got some of our modules mixed up, and that's all we need to say about that. But we had good proven modules, and then we somehow got one or more modules that were not. So it was an honest mistake.
Oh yeah, no problem.
Yeah, I mean, don't even feel bad about it. Over the last year or so, I've seen that just so much more than I used to. A lot of people are buying modules from maybe not the best sources, not like certified, DIY EV parts sellers, because that's expensive. But a lot of the time you should know why was this Tesla pulled off the road? Because a lot of Teslas get pulled off the road because their batteries are no good anymore. A lot of them get pulled off the road because they've been in a crash. How has that affected the cells? Even visually, they may look fine, but internally, the voltage may even be fine, but internally they're damaged.
So moving right along in the interest of time, if I think you covered this question. If you were to put like an amp meter on these on the battery leads, it's only, you said 200 milliamps.
200
right?
milliamps, yep, and only two cells per LTC group of 12 or 18 cells at a time.
Okay.
So
this would put Ron. This might be a good time to look up that video.
Your video still processing. Let me just try it. Yeah.
Right. Normally, if it's not balancing, it's far less than 200 milliamps per balance lead, right? It should be
basically immeasurable. Yeah.
right.
There's actually the satellites, the BMS, it sleeps when you turn it off, so that it's not consuming quite as much power from the module. But even when it's on, it's so small, it's basically not measurable.
Gotcha. Now, just to kind of like layman's question, are all battery management systems the same? How do you judge them? Can I just buy the crap on Amazon? What would be your judging criteria from a consumer, advice? What would you say to us?
Yeah, I think there's three things. I think one that everybody's familiar with is like the dailies of the world.
Oh yeah, I use them. Yeah.
Yeah. No, they're fine.
No, it's okay. I mean, you can tell me they're not.
I have coworkers, friends, who will laugh when I say that daily is fine, but I've seen them work plenty of times, so they can be fine.
It's like the one I have in my bike.
Yeah, exactly. Like they have
their bicycle great, and
they have their place. Yeah, but I think the key is, and there's a lot of BMSs out there like this. That's like a BMS that requires you to run the main pack cables through it, and it will disconnect if there's a problem, like any BMS, but that's kind of like its only way of interfacing with your system. That's fine on an e-bike, but that's not really okay when you start talking about 96, 144, 312 volts, 800 volts. It just doesn't work the same. Then you start talking about systems like Thunderstuck.
Wait, sorry, 1 second. Do you mean like this, where it goes through the system like this?
Right. Yeah.
Okay.
the second type of system, like the Thunderstruck, Orion, AM, etc., E-Lithium, anyway, all those, they're not going to have, if anything, they'll have a voltage sensor on the pack, but that's it. That's not going to have main pack current going through any component in the system other than the current sensor and the contactor, because its job is not to stop things like that. It's supposed to stop things in a more intelligent way.
By what? Talking through the CAN bus to your charger or to your controller. Is that right?
Exactly. Yeah. And I think it's like,
you don't like the brute
there's like a
force,
hierarchy.
just cutting it off. You want a conversation?
I'd love to see it.
Well, the problem I had with some of those too, and especially the cheaper ones, is I was just riding my bike and it just quit on me. It just cut out, and there's no indication of why.
Right.
What fell off? Is there a problem? Which cell has a problem or anything? Or it didn't give me any warning before that or any limp home mode. It was just dead.
Right.
So
right. Yeah, it's only method of communication.
It would reset itself, and I would ride, and then it would die again. So
Right.
some of these do have Bluetooth interface to them, and an app for your phone so you can look at them.
Right. Right. Yeah. In most cases, the only method of communication is you're done. You know.
Yeah, it just shuts off on you.
Yeah. Yeah.
Sounds like my ex-girlfriend. No.
And they use FETs, like they use solid state relays to allow current flow. You can't do that when you start talking hundreds of amps as well, and hundreds of volts either. That just doesn't exist really.
You want a big fat contactor, right?
Yes, yeah, exactly.
Nice.
I want to hear the click.
Yeah. It's so funny when you walk up to a Tesla. If you pull the door handle, you're gonna hear that within a second or two. You're gonna hear that click, just like on a DIY vehicle. It's pretty wild.
Yeah.
Delayed click.
I like
Kind of click to clarify.
Yeah.
Yeah, I like the a lot of older conversion. I mean, a lot of conversions right now, and a lot of older EVs when they've got like a large series of contact. They got like a bunch of like accessory circuits. So you turn them on, it's like clunk, 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 clunk. I always like that a lot.
Yeah, you should hear. That's what it sounds like on the Torque, because it's a DC system. So it's actually, they have a bunch of contactors that are used for reverse, because it actually reverses the polarity on the motor.
Yeah. I've worked on a few DC systems, and I think most of the time the solution is to hit the contactor with a hammer.
Whereas that, I always keep a hammer handy. Really.
Yeah.
Yeah, don't worry, it's not welded together. Just give it the old Fonz, you know?
Yeah. That works about 20 times, and then it doesn't close.
Yeah.
Right.
Yeah.
Or if they've welded together or welded open.
Yeah.
60% of the time it works every time.
Yeah. I got a silly putty question here. Okay, so I'm a car guy that got into engineering, or conversions and shop class and stuff. But coming from just like literally just gasoline, computers were like the moon to me. And I'm not speaking for other people in this room, just me. Computers were the moon. Programming was on a different world. But obviously, I do enjoy looking at the putty and looking at the terminal and this, that. But my question is there any other way to interact with the BMS than the silly putty terminal? And I call silly putty because the name putty just invites it. It doesn't make any sense to me. Like it's like, come on. So why do we have to interact with it with such a dry terminal? Is there another way to do it? And I think Kev probably has some answers for us as well. But Kelan, what do you think about the interaction between the human and the BMS?
You're really insulting my baby here. The terminal is just so amazing. I like that you say that programming was like the moon to you, because I am pretty sure the processor and the interface is not much more advanced than what took us to the moon.
Oh.
Which is if anybody here knows anything about like the Saturn V, it was not very impressive actually.
Oh yeah, it was basic.
Yeah, I mean, there's other terminal programs. You can do it on your phone. You can do it with other nice terminal programs. But the short answer is not really. I haven't got anything for you It's on my wish list though.
Right, to make a more graphical, Windows friendly, modern looking interface. Like when
Yeah.
you're programming the Hyper 9, they have their nice graphical
Right,
interface
right.
for setting
Yeah.
things. But the honest answer is on a BMS, you should have to configure it once and probably never go to the PuTTY terminal again.
Once, yeah. It would save me a lot of work though. I mean, there's no doubt. It's not super intuitive, especially these days.
Right.
Okay.
It's back to when I learned to program in the 80s. That's what it looks like. So
Yeah. I mean, there's also I should give the engineering perspective because you guys got a feel for us sometimes too. Designing like a safe system, including all the features that everybody needs, all the testing, that would be about the same level of work as like a high quality GUI, and I think we should do it. It's definitely on the on the list. But quality graphical user interfaces are challenging, really hard.
So this is I forget the program, but this is what Eddie over at
I'm gonna
Revolt.
show it. Hold on.
So do we see the presentation?
Do that. Yeah. Now you can see what you're showing, right?
Yeah.
He's got a little video he wants to show that he took over at Revolt. Go ahead, you introduce it, Talik.
So yeah, Eddie he actually configured, it's a customizable interface here. So he's a very graphical person. And so if you can see the big colored bars on the right, the thick bar is the high voltage pack and the thinner bar is the low voltage pack. And then these 6 grids here are the modules over here.
Now, I also have kind of proportioned this out into.
It's
Here and it's
too,
lagging.
it's too dense to load the audio, but he basically goes through to talk about how he configures it so that he can see all the information the way he wants it. And that lower right, the blue and green, that's actually his CAN bus. So when he first plugs in this laptop, if he doesn't see the CAN bus working, or he checks to see if the CAN bus is communicating before anything else here loads up. But I thought this was a really nice graphical presentation of all the information there. It also has it's a live view. You don't have to hit refresh of show cells or whatever.
Cool.
Yeah, that is awesome. No kidding.
well, and like in the bus, the next step was to, like we did on the cart, there's a nice little AEM display, and they have their graphics software so you can configure it and lay it out, and you can have a screen that would just show all the battery information that the PuTTY terminal does in a nicer way.
I think that is AEM. I think that was AEM.
Oh,
Yeah,
the software.
Yeah.
Okay.
And I just like to put it in here that, that's not the BMS's job to be the GUI, right?
Yeah.
Like Kelan was saying, that has to be a reliable piece of software, and a GUI is hard to test in all conditions.
You'd have to split it into two. a GUI and reliability cannot exist in the same world. It's too incompatible.
That's totally fair. I would rather the dry, accurate PuTTY than I guess what you guys call a GUI, which would be a graphical, thing. That makes totally sense.
Yeah, you can see all the cell voltages on your AEM, on your $800 AEM display.
Right. Yeah, I mean, I must say too, like when it comes to instrumentation, just showing data, when you start stepping outside of configuration, like the technician's job, there's lots of options out there these days. It's really nice. Speed HUD gauges, the AEM display is all great. We have our own display as well.
Nice. Let me go to Jonathan. He had a question.
Yeah, I was just going to mention that too. I just recently got the dilithium display and got it working. And I don't know if there's any information that you can't get through that you would get through PuTTY, other than doing the configuration through PuTTY.
Right.
It pretty much gives you all the cell information. Is that right?
That's correct. Yeah. I mean, there's small stuff like anything that you really need for an actual user of a vehicle. Yeah, it's all there.
Nice. Now, before we get to the last question of the night, because we're kind of going to wrap up was there anybody that wanted to jump in and add something? I know that, Ali has done a lot of wiring, and I was wondering if he had a question, and Omar's listening, and there's a lot of people on the call in listening mode, including Mark and some other people. And so if anybody had a question, you should jump in now. Omar, you got nothing? Come on. Okay. All right, Mark, you got anything for us?
No, I'm just kind of taking it all in. I figure if I know what I know and then I just listen and take it all in, then
no problem at all. Okay, Richard's got his hand up. Go for it.
Yeah, I was just going to repeat what I put in the chat there to ask Helen. Is there a way on the BMS to measure cell resistance?
Yeah, it's kind of funny. There's really no way to measure cell resistance directly at all. Like fundamentally,
it's
hard
to do. I know.
Yeah, it's all algorithmic. We don't really support, like we consider cell resistance when it comes to a resultant behavior, failure, creating a safe system, but we don't process and present that information to the user. I think most of the time, technician who's been around the block once or twice will identify the issue pretty rapidly and fix the problem. In the end, it doesn't become a useful piece of data to the end user.
Okay.
But is cell resistance an indication of a problem with that cell?
Oh, sure. Yeah, it definitely is. But just like in a Tesla, like if you start seeing problems with your pack, degradation, high resistance, things like that, the resulting behavior is just less capacity, and it's the same here.
Okay, Tom's got his hand up. Go for it, Tom.
Yeah, I really gleaned a lot of info from this call, and Sarah was a little bit self-conscious about her issue, but I think it was totally germane to me to bring this, and that's why I asked the question about numbers. So this has been a really beneficial call. I'm a retired Marine engineer who, basically that means a jack of all trades and a master of absolutely none. And, I've got, Ohm's law. But when we ran into trouble, it was just basically remove and replace. And we couldn't diagnose a lot of stuff because we just weren't sophisticated enough. And now I see at this late stage in life that some basic understanding of resistance and Ohm's law is just really so important for what we're trying to do with these EVs and especially EV conversions. So just want to register my gratitude for all of this. I guess we'll see you guys next week, huh?
Yeah. Let me champion this just for a sec. I'm a high school shop teacher. That's my day job. I have a side business and I volunteer and all kinds of stuff. But, it's not until, for me and a lot of my students, it's not until you learn through failure that you actually really feel like you've learned something. And when it comes to the Ohm's law or V equals IR, you really got to lay out a circuit and then measure it and see the math problem actually add up. What's crazy about electricity, and if this helps anybody, you can measure it like you're using a calculator. You can divide voltage if you have two equal resistors. You can do amazing things that you didn't think were reliable. It's reliable. You can predict it and then prove it out like an old school algebra. It's algebra, basically.
Yeah.
Right? Is that fair to say that, Kelan?
Oh my God. It is my favorite thing about EVs, about designing, building, and working on EVs. Like I was a car guy first, EV guy second. When you're a car guy and you're doing like thinking about tuning and efficiency and power and torque, everything is like magic. You can't you can't sit down and go, what's my displacement, my volumetric efficiency, and come up with a real number in the end for what it's going to do. You have to test it. But in the EV world, it's completely different. I can pick a couple components, look at their spec sheets, and tell you exactly how that vehicle is going to operate before it exists. And it's one of the coolest things ever. I can look at the display and like see, you know, I push the pedal a little bit, see the voltage drop. That represents like a level of efficiency that you can calculate. And there's so many cool things that you can do with very simple data in this world. I think that's just one of the most interesting parts of it.
That's cool, man. That's great to hear your insight. I really appreciate you coming in tonight and sharing in the EV community. I do have one more question, but also Omar has a question. Go for it.
Okay, so I'm new to all this, and I'm learning kind of what's possible. Yesterday I was with Kevin. We took apart that rad power bike battery, and there was a BMS there. We're currently working on a project. I donated this. It's called a Honda Odyssey. Remember those old Odysseys from the 80s? I donated to a friend who converted it to electric. That was my dream, but he was able to pull it off. I wanted, you know, my idea for that is to have a swappable battery, custom built. And I'm just curious about the BMS system. And have you seen swappable systems and the BMS systems? You have that for a swappable 5K battery?
Absolutely, totally. I've seen it done. I think it's awesome. There's a company up here in Santa Rosa that we work pretty closely with, more in the past, but they do electric tractors. It's called Select Track. The details aren't important. The important thing is they had big swappable batteries because you can't have any downtime to charge for like an hour or two. So when the battery got depleted, they go pick up their fresh battery and put down the old battery to charge. Definitely, it's very doable. There's kind of a few ways to do it. One is you have, I'm going to think in my Thunderstruck's world because it's simple for me. Like you have the MCU and all the satellites in each dedicated, like as a part of the dedicated battery, and then when you swap that, turn the system off, swap that battery in, it connects with the same, you know, CAN bus interface. Everything in this world is CAN bus, so you use CAN bus, and it reconnects with the rest of the system. Everything's good to go. Turn it on, you're on your way. The other way of doing it is like a little bit of cost savings. You have like the MCU on board, and then you just use that little ISO-SPI, the isolated serial connection to the satellites, and it'll do the same thing. It'll yell at you when you unplug it because it goes, where'd all the cells go? There's something wrong. But when you plug it back in, it won't even complain. It'll go, all right, on to the next thing. Let's go.
Cool, great. Yeah, we're looking at something you could carry, a couple batteries and hot swap here out in the desert.
Yeah, sure.
We saw like in that in the rad power battery, it was hot swappable because the BMS is inside the battery. It's all one piece. You can pull it out, put the next one in, and that's the architecture like what Kelan's talking about. The BMS stays with the battery. That's probably the best case for that. And then when you swap it out, the new battery has a new BMS.
Yeah, there's usually the best thing to do and then the cheaper thing to do.
Yeah.
Like Zero Motorcycles, I think, has this as well.
Cool. So let me hit you with two last questions, and I think they're kind of related. How does the DC, if we can do it, how does the DC fast charging affect your BMS on, you know, like a DIY car? And then where do you think the future of battery management's going? Like, is there anything new? Is it going to stay the same? Is there anything we should know about? What do you think, man?
Oh, man. Geez, DC fast charging. What a can of worms. In the old days, it would be pretty trivial for the hardware of the BMS to do DC fast charging itself. Like CHAdeMO, which is going the way of the dodo. And I just today somebody told me that old NACS, old Tesla DC fast charging was using CAN bus as well. So that too would have been relatively trivial. But these days, because there's a very specific hardware and protocol that you need for CCS and modern NACS, it's all going to be done by an external controller. The one that we support is Felton. Felton has a nice CCS controller if you're willing to put up the money for it. And we support CHAdeMO directly. Like I said, it's relatively trivial, but I think another consideration is really pack design. Things don't change that much from the BMS's point of view. It's just more amps. it's just more of what it does already. But if you don't have a well put together pack, a well designed pack, if you don't understand what's safe and what you really can do, then you're going to run into problems.
Sorry, I'd like to also add that many conversions don't have a cooling system, and that comes into play with fast charging is thermal management.
Yeah, absolutely. We've been talking about cell resistance a lot. That's where the heat comes from. So every cell has resistance. So picking a lower resistance cell that represents a lower voltage drop or increase for charging will help you out. But because a charge occurs over a longer period of time, cooling is often necessary if you really want to charge fast. Yeah, definitely.
Cool. And and in the interest of time, where do you think the future of the BMS is going? Is there anything new coming down the pike? What do you think's going on in the next 10 years?
I've seen a lot of new revolutionary things in the world of here's a complete system. It's just a bunch of boxes and you put it in things. Electric Classic Cars does that with our technology. A few other people do as well, but a lot of people are doing it from scratch. I think that's a new thing that's kind of been missing up until this last year. I went to SEMA, and I was really impressed by the number of ready to go systems that existed. I don't think much is going to change in the way of the electronics, just the way that they process information, how it displays to the user is going to be improving more and more for everybody. And I want it to be more affordable. That's kind of Thunderstruck's deal. We try to bring this to everybody who has a garage and a desire to build an EV. So trying to do more of that as well.
Cool. Well, this is awesome. I really appreciate it. Every week we're going to have topics that tackle the what's on the DIYer's mind, and we're trying to educate people and share ideas. I think sharing our failures is probably one of the best ways to do it. I know that I've failed a million times with all this stuff. I got some dead batteries over here too. And Kelan, thanks for coming in. It's so awesome, and it's so good seeing everybody. Look at all the good people that are part of this conversation. So we're going to end the recording there in the interest of time. And Omar, you got a quick question? Go for it.
Hey, Kelan, I just wanted to show you what I've got, a Thunderstuck motor. If I could, my sailboat.
Oh, yeah, his boat there.
Oh, you got a sailboat? Oh my gosh, no way. No way. That's one of our 10 kilowatts, right?
Yeah, it's the Savcon controller.
Right.
I've spent some time under the deck there getting that thing working again.
Where are you at, Omar?
San Diego.
Okay.
So there it is.
Looks cool.
Yeah.
Very good installation. That's it's better than most.
It was very cleanly done.
There you go.
Maybe we can have Kelan back to talk boats on another session.
Oh, that'd be awesome. We could do boats versus EVs or electric cars. But in the interest of time, we got to keep going. Tom, keep it short. What do you got?
Yeah, I was just going to let Kelan know that down here in San Diego, we're not all just car guys, although many of us are. We got a few boat guys here, and really would like to invite you to stop in and check in on us at the Electric Vehicle Learning Center in San Marcos. If you ever get down this way, we're always looking for people that are instructor level guys who might be able to do a 4-hour or a 1-day class. So really thank you a lot for being on board today.
Yeah, we're right across the parking lot from EV West. So
oh, really? That's cool. Yeah, yeah. I appreciate the opportunity to be here so much. I'll probably take you up on your offer at some point. I love education. It's one of my favorite things in this industry and in the world. I tried to play the biggest part I could in the legacy training program. So I hope that you guys are able to exceed even their expectations. So
nice, cool. Okay, well, hate to cut it short, but I gotta get going, and I really appreciate you joining us and everybody being here. And this is really becoming a thing. It's great. We get to talk about the EV problems, and we get to solve the problems together as a community. So pretty cool. All right, tune in next week. Thanks a lot. We're gonna end the recording here. You guys can hang or go, and I'll see you soon.
My pizza just got here, so I'm going. I'll see you.